दोस्तों तैयार हो जाइए महा बचत सेल के लिए। इससे बढ़िया मौका नहीं मिलेगा जहां आप मजे ले सकते हैं बचत के। मे यू सेव मोर, यही है हमारा वादा। इस 28 से 31 मई सभी सुपर कोचिंग पर आपको मिलेगा अप टू 90% ऑफ एंड 50% की एक्स्ट्रा वैलिडिटी। ये वो मौका है जहां आप अपने सपनों को साकार कर सकते हैं, आप अपनी ख्वाहिशों को पूरा कर सकते हैं। तो अगर आप तैयारी कर रहे हैं एसएससी, बैंकिंग, टीचिंग, यूजीसी नेट, सीएसआईआर नेट, ईपीएफओ, स्टेट पीएससी, यूपीएससी, डिफेंस जैसे एग्जाम की, तो आइए इस महा बचत सेल में साथ मिलकर धूम मचाएं और अपनी सेविंग्स को यादगार बनाएं।
Hi, good evening everyone. This is Shefali Singla, and in the session we are going to discuss the concept of B3 and B plus tree in more detail. So this will be our second last session from DBMS. Tomorrow we'll be talking about the timestamp based protocols, and after that I'll be starting with the next subject. So those who have joined the session, guys, quickly give me the confirmation. Very good evening, Shubham. So yesterday we talked about multi-level indexing. That was starting multi-level indexing. Then we had a look over the few advantages and disadvantages of static multi-level indexing, because when we were recording when we were adding or inserting a record in the static index file, then there was the problems coming up like overflow of the blocks, or it might be resulting into shuffling the entire database file. अगर पूरी database file को shuffle करते हैं तो definitely whole index file will also shuffle. So that was not a good idea. So in order to overcome the problems of the static multi-level indexing, we have discussed that why dynamic multi-level indexing comes into the picture. Then in dynamic multi-level indexing, we have two data structures. One is B tree and B plus tree with minus changes. So we talked about the difference between B tree and B plus tree, right? And on the basis of that, we talked about four formulas that were those were based on the structure of the node. So we talked about the structure of internal node and leaf node of a B tree, and internal node and leaf node of a B plus tree. So anyone having any doubt in these concepts? Anyhow, I'll be talking about in more detail about the B tree, how the elements can be inserted in a tree, or how we can construct a B tree if you are given with a set of records, and same goes with the B plus tree. And we'll be talking about the different types of questions that can be asked on the basis of dynamic multi-level indexing. So anyone having any doubt in the differences, or why we are covering this concept, or where is its application? I guess there is no doubt. All right. So first of all, let's have a quick start with a B tree. So we have talked about one term, that is the order. Order means simply the maximum order represents the maximum number of block pointers in the B tree node. Maximum number of block pointers agar 3 hai, let us assume that order is 3. That means it will be having block pointers. Block pointers means child pointers. So there will be 3 child pointers. Agar 3 child pointers hain, तो कितनी keys आ सकते हैं? How many slots we have? We have 2 slots. That means number of keys possible are maximum keys possible are 2. Similarly, if the order of a tree is 4, if order of a tree is 4, then the maximum number of keys will be how much? Order of tree is 4 means 4 child pointer can be there. There are 4 child pointers, so how many keys can we store? There are 3 slots available, so in this case maximum keys will be 3. So can we generalize this? If the order of a tree, if order of B tree is given as P, can you tell me that what will be the maximum number of keys possible then? Order of a tree means maximum number of block pointers or a child pointer are P. Then what will be the maximum number of keys that we can store? See, maximum वाली condition हमें तब check करने की जरूरत है when we are inserting more elements in the existing nodes or in the existing tree. ओके एंड मिनिमम वाली कंडीशन हम तब चेक करते हैं जब हम एलिमेंट्स को डिलीट कर रहे हैं, बिकॉज देयर इज वन कॉन्सेप्ट दैट एटलीस्ट देयर शुड बी 50% occupancy except for the root node. There is just the exception for the root node. Apart from that, each and every node has to contain at least 50% of the keys, right? So maximum number of keys possible will be, अगर यहाँ पे order 3 है, it is coming out to be 2. If the order is 4, it is coming out to be 3. If the order is P, definitely it will be P minus 1. Okay, आपको सिर्फ order given होगा. Nobody is going to tell you that how many keys, maximum number of keys you can store in a node, or what will be the minimum number of nodes. Now next one is maximum. This is representing the maximum number of block pointers. I'll be writing if BP, that means I'm referring to block pointers. And if I'm writing RP, that means I'm referring to record pointer. Record pointer is also known as data pointer. Record pointer, or you can also call this as data pointer. So maximum number of block pointers are BP. So on the basis of this, minimum number of block pointers, minimum number of block pointers. Since it has to satisfy minimum 50% occupancy, that means it will be P by 2. Now question arises is, should I take here the flow value or the seal value? Let us assume the order of a tree is 5, 50% occupancy means 2.5. अब 2.5 child pointer नहीं हो सकते, either it will be 2 or it will be 3. So अगर 2.5 की floor value लेते हैं minimum block pointers, minimum 50% occupancy means कम से कम 2.5 होना चाहिए. So if I'm taking this as 5.2, that results into 2.5. If I'll be taking its floor value, that comes out to be 2, right? But 2 is not possible with minimum 50% occupancy, that is 40%. तो हमें minimum 50% चाहिए, यानी कि 50% or more than 50%, anything is allowed. So here more value means we will be taking here the seal value. So please take care of this point. Everywhere we will be taking this as the seal value. बट आई रिकमेंड यू कि आप इन चीजों को रट्टे मत मारो कि कहाँ पे फ्लोर वैल्यू लेनी है और कहाँ पे सील वैल्यू लेनी है. इट्स ऑलवेज गुड टू कीप इन माइंड दैट व्हाट इज द कंडीशन एंड according to your formula what answer you are going to get. So automatically it will give you an idea that whether you should go for the seal value or for the flow value. Alright, so if minimum number of block pointers are P by 2, then definitely minimum number of keys will be P by 2 minus 1, because we know that the keys are, let me write here, keys are 1 less than the number of block pointers. Make sense? So on the basis of this, we can return the minimum number of keys. Since the minimum number of block pointers are P by 2 and key is 1 less than the block pointers. We will be using this maximum condition while inserting the elements in the tree. We will be using this minimum condition when we will be deleting the elements from the, deleting the keys from the tree. Any doubt on this point? All right. Now, if we talk about the node structure of a node, structure, B tree, structure of internal node. Since B tree is a multi-way search tree, so if we are storing here the elements in the B tree internal node corresponding to every key, there is a record pointer. So let's assume that the number of block pointers are P, or the order of a tree is given to you as P. This is the order. Order P का मतलब क्या, हमारे पास block pointers कितने होंगे? There will be P block pointers. Let me call this as block pointer 1, block pointer 2, block pointer 3, and so on. Like this, we will be having P block pointers. Okay, so and here we will be storing the keys. Let's say this is block pointer 1, block pointer 2, block pointer 3, and since the order of a tree is P, so there will be P block pointers. Now here we can store the key K1, K2, K3 like this, and here we'll be having P minus 1 keys. Correct? After that, corresponding to every key, there is a record pointer because here it is not going to support the sequential access. Record 2, record 3, and RP minus 1. Now, what about the arrangement of these keys? We have already said that all the keys within a node, all the keys within a node should be in increasing order. That means K1 is less than K2, K2 is less than K3 like that. So this is always in the increasing order or in the ascending order. Now, whatever second condition we have said, since this is a search tree, so जो भी elements K1 से smaller होंगे, it will be a part of the left child of the K1. So here, if X key is there, its value should be less than K1, right? Its value should be less than K1. And here, whatever elements will be getting, then that will be greater than K1 and smaller than K2. K1 greater than K1 because it's present on the right hand side, and K2 say smaller hoga because it's present on the left hand side of K2. This is the condition. Or let me call this as Y because this is not the same element. And similarly here, whatever element will be getting here, X, Y, let me call this as Z. So this Z, since it is present on the right hand side of K2, so it will be greater than K2 and less than K3. And here, whatever element we will be getting, let's say Q, since it is present on the right hand side of Kp minus 1, so it will be greater than Kp minus 1. This is how we have to store the elements. Make sense? So this is the structure of the internal node. So we have already written the formula in the yesterday session. So in a block, what we are storing? We are storing P block pointers. In one block, we are having P block pointers, 1 से लेकर P तक जा रहे. Along with this, we are having P minus 1 keys. And we are also having the record pointers. How many record pointers we are having? We are having P minus 1 record pointers. And this should be less than equal to the block size because it should fit in one block. This is the formula for the internal node. Make sense? At least 50% occupancy should be occupied. That is the another important point. For all blocks, at least 50% occupancy must be ensured except for root node, or you can say that root level. Root level पे एक ही node होगी, so there is the exception for that node. Fifth, next point is the structure of leaf node. Leaf node means there is no child. Structure of leaf node, that means there is no child for a node. Since the order is P, so definitely we can store P minus 1 keys. This is a leaf node. And since it's a leaf node, no child is there, तो यहाँ पे ये जो block pointers हैं, these all will be pointing to null. That means no block pointer is required here. Okay, these pointers will be pointing to null. no child is there. And here obviously we will be having p minus 1 keys. So let's write here k1, record 1, k2, record 2, because corresponding to every key there is a record pointer, k3, record 3, and so on, kp minus 1, rp minus 1. On the basis of this, can you tell me that what will be the formula of the leaf node? क्योंकि ये जो formula हमने लिखे, that is also coming from the structure of a node. If you are comfortable with the structure of a node, तो आपको कुछ भी टेंशन लेने की जरूरत ही नहीं कि फॉर्मूला क्या आएगा. So easily you can return the formula. What will be the formula here? In a node, there is no block pointer because this is a leaf node and we have p minus 1 keys. Corresponding to every key, we do have a record pointer. So p minus 1 record pointers are also there and it should fit into one block. Straightforward questions आएंगे. I'll show you tomorrow that what sort of questions have been asked. बिल्कुल directly ये formulas use करने. Block pointer size will be given to you. Key size, record pointer size, and the block size will be given to you, and you will be supposed to find out the order of a tree. That means you have to find out the value of p. Is this clear to everyone? This is the formula for the leaf node of the B tree. Make sense? Now let's talk about if we want to construct a tree from the given set of elements, how to do that. So we want to construct a tree with degree 5. Degree is given as 5 or order is given as 5. What does it mean? Guys, what do you understand by degree of a B tree is 5? Hurry up. Quickly. What is the meaning of degree of a node is degree of a tree is 5? Maximum of 5 children. Very good. So this means that maximum children, or you can say that maximum number of children or maximum block pointers are 5. Children or maximum block pointers are 5. अगर maximum block pointers 5 हैं, then in a node how many maximum keys you can store? If maximum number of children या maximum block pointers 5 हैं, तो एक node में maximum कितनी keys आ सकती हैं? Right now we have discussed all these points, right? Very good. Hurry up. What are the maximum number of keys possible in a block? See, if you'll be writing the answer in the chat section, I'll get to know that you guys are getting the concept. Yes, so we can store 4 keys in a node. So let's start constructing the node. Initially tree is empty, tree में कोई भी node नहीं है, तो हम first node से creation start करेंगे. All the elements within a node should be in the ascending order. We can store maximum of 4 keys. Since this is a first tree, so I'm drawing it properly. So we can store 4 keys. Okay, so take the first element, that is 5. So I'm so sorry. This is 5. We can simply store 5. It's inserted. It's in the ascending order. No problem. Next one. 10 is coming up. So we have just one node, 3 empty slots are available. It will be added to this slot. This is still in the increasing order, so we need not to do any sort of shuffling. 12, it will be inserted here. 13, it will be inserted here. यहाँ तक कोई problem? कोई problem नहीं. Now 14 wants to join this tree, तो 14 को आना है, but there is no empty slot. That means node is full. एक node में आप maximum 4 keys को store करवा सकते थे. Now this node is full, so we will call this scenario as the case of overflow. When there is a case of overflow, we'll go for node splitting. यानी कि हम इस node को divide कर देंगे. Divide किसके basis पे करेंगे? On the basis of the mid. So whenever there is a scenario of the overflow, we'll go for node splitting, और जब भी हम node को split करते हैं, it's always done on the basis of the mid. So now we are having the elements like 5, 10, 12 और 13. इन 4 एलिमेंट्स से तो नोट स्प्लिटिंग की जरूरत ही नहीं थी. ओवरफ्लो कब हो रहा है? व्हेन वी आर इंक्लूडिंग 14. So when we are going to split this, middle element is 12, so 12 will move up. Okay, so here 12 will move up after the first node splitting. Now when we were adding the element 14, first node splitting is going to take place. Sometimes in the exam they may ask for the number of node splittings and you'll not be given with the options, because agar number of node splittings pe question aaye, that will be under the numerical answer type question. So here we will be splitting this node on the basis of 12. तो आपको पूरा ट्री स्टेप बाय स्टेप बनाने की जरूरत है. आई एम जस्ट राइटिंग हियर 12. हम एक नोड में 4 की स्टोर करवा सकते थे. मिनिमम कीज कितनी आएंगी? 2. बट देयर इज द एक्सेप्शन फॉर द रूट नोड. तो रूट नोड पे एज ऑफ नाउ वी जस्ट हैव 1 की. Okay, there is the exception for root node, so there is only 1 key, and whatever elements are present on the left hand side, it will be a part of the left block, and whatever elements are present on the right hand side, it will be a part of the right block. Okay, so here we have the elements. Left side पे हमारे पास elements आएंगे 5. We can store 4 elements at max. So 5 is already present, 10 is already present, and on the right hand side we will be having the elements 13, 14, 13 and 14. This is the result after splitting this node. Any doubt in the first splitting? Splitting clear हुई, right? I'll consider the next example with the degree 4, जहाँ पे आपके पास 4 keys होंगी, so you can either take the second element or the third element. We'll talk about that later. Let's not mix the concepts. यहाँ तक clear है, right? So 14 के लिए node splitting has taken place. Now next element is coming up 1. कैसे find करेंगे? Since this is a search tree, just like the binary search, we will be looking for the correct position or correct node for the new coming element. तो यहाँ पे 1 आ रहा है. Since 1 is smaller than 12, it will be compared with the root node. 1 is smaller than 12, so it will be going to the left tree. अब 1 को हम यहाँ पे add नहीं कर सकते because elements are not in the ascending order. So 1 is smaller than 5. So here we will be having 1. Here we'll be having 5, and here we'll be having 10. 1, 5, 10. Element is inserted. Take the next element 2. 2 is smaller than 12, so it will be going to the left side. So here we'll be having 1, 2, 5 and 10. So let me replace this. So here we will be having 2, 5 and 10. So the elements of the node are 1, 2, 5, 10. This is what I mean by arranging the elements in the ascending order within the node. 2 is inserted. Next element is 4. 4 is, check for the position of the 4. Since 4 is smaller than 12, so it is going to the left side. अब यहाँ पे जब 4 आया, this is a case of overflow. When it's a case of overflow, again we'll go for the node splitting. Okay, so here when we'll be splitting the node on the basis of what element will be doing the splitting. Now we are having the elements 1, 2, 4, 5, 10. अब 4 को end पे नहीं रख सकते हो. You have to keep them in the ascending order. Since the middle element is 4, so 4 will be going to the root level. Okay, so after the node splitting, here we'll get, now at the root level, 4 elements are possible. अभी एक ही था, so now 4 is also joining at the root level. Leaf node से element has moved to the internal level, so this comes out to be 4 and 12. Obviously here we have 4 slots, like जैसे आपके पास normal node में होते हैं. Okay, so to the left of 4 we will be having the elements. Left of 4 पे 1 and 2 is available, so here we'll take a node and elements 1 and 2 are there. 1 and 2. 2 slots are empty. To the right of 4 and the left of 12, we have 5 and 10 available. 5 and 10, 2 slots are empty, and here to the right of 12, there will be no change. This is 13, 14 and empty. ये क्लियर है? इसके बाद मैं फटाफट से सारे एलिमेंट्स ऐड कर दूंगी. This is what we will be keep on doing in order to insert all the elements in a B tree, and finally at the end we'll return the total number of node splittings. Make sense? ये clear है? So let's quickly add the remaining elements. Next element is 20. 20 is greater than 4, go to right side. Greater than 12, go to right side. So 20 will be added to the right side of 12. Next is 18. 18 is greater than 12, so it will also be going to right side. So here we'll get 18 and here we'll get 20. Next element is 19. 19 की वजह से यहाँ पे overflow scenario आ रहा है. So we will be going to split the nodes. So here next node splitting is going to take place. So this will result into node splitting किसके basis पे होगी? 13, 14, 18, 19 and 20. So 18 will be going to the internal level, 12 and 18. To the right side, we have 1, 2, 1 and 2. To the left side, we have 5 and 10. बच्चे एक बार फटाफट से confirmation दे दो, ये चीज clear है? In this case, I'm not considering the concept of the key redistribution. I'll be introducing that in the same question, but on the next slide. ये जो हम कर रहे हैं, this is without key redistribution. So here we have the elements 19 and 20 available. 19 and 20. Next element that is coming is 17. 17 is greater than 12 and smaller than 18, so it will be added here. 16. 16 is greater than 12, smaller than 18, so 16 will be coming somewhere here. Next, 15. 15 is greater than 12 and smaller than 18, so it has to come here, but it's a case of overflow. So for 15, overflow condition arises, so here we'll go for node splitting. It will be 4, 12. अब यहाँ पे किसके basis पे splitting होगी? 15. So 15 is coming here. We have to arrange that in the ascending order. 15 and 18. To the left, we have the elements. आपको पता है node कैसे बनानी है, right? We have the elements 1 and 2. Here we have the elements 5 and 10. Here we have the elements 13 and 14. Here we have the elements 16 and 17, and to the right of 18 we have the elements 19 and 20. So this is done. Now next element that we are getting is 25. I purposefully took the lengthy example so that you get comfortable with the insertion of a node in a B tree. So 25, since 25 is greater than 18, so it will be going to the right side. Next element is 23. 23 is greater than 18, so it will be going to right side. So here somewhere here we will be getting 23. Next is 24. It has to go to the right side. This is a case of overflow, so again we'll go for node splitting. For 24, node splitting is going to take place. किसके basis पे करेंगे? 19, 20, 23, 24 and 25. So obviously this 23 has to go up. Already the root level is also full, so again the splitting will take place, यानी कि it is going to increase the level of a tree. एक नया level यहाँ पे create होगा. Let me hide my image because I want to utilize the space. Okay, so now here it will result into 4, 12, 15, 18, 23. So 15 has to go up. यानी कि अब आपके पास एक और level आ गया जहाँ पे we have the node 15. To the right of 15, we have 4 and 12. And to the left of to the right of 15, we have 18 and 23. 18 and 23. Are you all getting this point? Now to the left of 4, we had 1 and 2. यहाँ पे आपके पास 1 and 2 है. Then here we had 5 and 10. Two more elements can come. To the right of 12, we have 13 and 14. It's on the left of 15 and right of 12. So same structure है 13 and 14. To the left of 18, we have 16 and 17. At every step, we are getting a search tree. That's why this is known as multi-way search tree. What is this E? To the right, we have 19 and 20. And to the right of 23, we had the element 24 and 25. Very good evening, Kanchan. Here we have the elements 24 and 25. Looks like a search tree? Yes. Now let's take the next element, that is 22. 22 is greater than 15, 22 is smaller than 23, so 22 will be inserted here. Next element is 21. 21 is greater than 15, go to the right side, smaller than 23, so it will be on the left of 23. So here we'll be getting 21 and 22. Next one is 30. 30 is greater than 15, go to right side. 30 is greater than 23, go to right side, so 30 will be added here. Next element is 31. 31 is greater than 30, so it will be present on the right hand side. Now 28 is coming up. 28 is greater than 23, so it has to come here. 28. So this is a case of overflow. So node will be splitted on the basis of 28. I'm not going to construct the complete tree again. Okay. So let me utilize the space in order to just represent this much. बाकी पूरे tree में कोई change नहीं आएगा. So this node will be splitted on the basis of 28. So here we'll be getting 18, 23 and 28. 18 के left में जो elements है, those are 16 and 17. It will remain as it is. To the right of 18, whatever elements are there, it will remain as it is. This node will be here. And to the right of 23 and left of 28, we will be having 24 and 25. And here we will be having the elements 30 and 31. Okay, but have you observed one thing? All the leaf nodes are at the same level. Note here is all the leaf nodes are at the same level. For 28, node splitting is taking place. Now, we have to add the next element. 28 is added, 29. 29 is greater than 28. So here we'll be adding 29. This is the resultant B tree. Count the number of node splittings. 1, 2, 3, 4, 5, 6 node splittings are taking place. But definitely इतना lengthy question नहीं आएगा. Now, in order to reduce the number of node splittings को reduce करने की ज़रूरत क्यों है? Because whenever node splitting is taking place, it will result into a more number of levels of a tree. Basically, this tree is representing the multi-levels of the index file. तो अगर number of tree के levels increase हो रहे, that means the number of levels of the index file is going to increase. And we know that the IO cost of accessing the data depends on the number of levels. क्योंकि हमने क्या बोले multi-level indexing में IO cost is equal to the number of levels of the index plus 1. So that means in order to reduce the IO cost, we want to have minimum number of levels of a B tree. Make sense? तो इसके लिए हम क्या करेंगे? Have you observed one thing? यहाँ पे this node was getting full, but इसके left side पे some slots were available. So that is known as key redistribution. That means instead of going for node splitting, we'll redistribute the keys among the siblings if it's possible, right? So let's solve this question, same question with the concept of with key redistribution. I guess I have a slide for the same. Okay. So with key redistribution, without key redistribution, clear है? Yes. Now, in order to reduce the cost, the number of levels of a tree or the multi-level index, we are going for the concept of key redistribution. So first four elements ऐसे ही आएंगे, that is 5, 10 and 5, 10, 12 and 13. 14 is coming up. There is no possibility of key redistribution, so we have to go for the node splitting. So it will result into 12 will go up. To the left of 12 will be having 5 and 10. यहाँ पे कोई possibility नहीं थी key redistribution की, so that's why we are going for node splitting. Worst case में तो node split करनी ही पड़ेगी, so this is 13 and 14. So first node splitting is taking place when we want to insert the element 14. Now next one is 1. So there is a empty slot available, so here we'll add 1 and 2. Then we have 5 and 10. 4 elements are possible. Next is 4. 4 wants to join here. This is a case of overflow. So instead of going, here is the point where we'll be going for redistribution. अब यहाँ पे क्या हुआ? This is asking a sibling कि भाई मेरे पास तो slot full हो गया, क्या आप इसको accommodate कर सकते हो? Then its sibling is saying yes, I have 2 slots available. So 4 जब आया तो here will apply key redistribution. This is a case of overflow. जैसे ही overflow आता है, instead of directly going for node splitting, we'll go for key redistribution. Now in this case, what will happen? Which key should be going here? 4 को भेज सकते नहीं भेज सकते, because if we'll be sending 4 here, it won't be a search tree. So the last element will be moving here and this will come down. That means it will result into, now the last element जब धक्का मारा तो 10 बाहर निकल गया, right? So 10 is going to the root level, and here we are having the elements 12, 13 and 14. So there was no need of going for the node splitting. So here we got the elements 1, 2, 4, 5. Correct? So no node splitting took place for 4. Next one is 20. Since 20 is greater than 10, so it will be going to the right side. So here we have added 20. Next element is 18. 18 has to come here. Now this is a case of overflow. Now it is asking its sibling, can you help me out? तो sibling is already full. तो जब sibling के पास भी space available नहीं है, then in that case we need to go for node splitting. किसके basis पे होगी? On the basis of the middle element. So here we'll get 10 and 14. I hope that the concept of key redistribution is also clear. So sometimes in the exam, they ask that what will be the resultant tree if we follow minimum number of node splitting, or in the numerical answer type, they may ask that what will be the minimum number of node splitting. So आपको exclusively नहीं बताया जाएगा कि आपको key redistribution concept use करना है. So minimum number of node splittings means automatically we will consider the concept of key redistribution. So here we'll get 12 and 13, and to the right we will be getting here 18 and 20. I know what elements are coming up, so that's why I'm leaving the space beforehand. 18 and 20. So second node split took place here. Next element that is coming up is 19. So let's then insert the 19 on the right of 14. 19 in the ascending order. Next one is 17. 17 in the ascending order. Next one is 16. So with 16, this is a case of overflow. So it's asking for the help from its sibling. Sibling is having 2 slots available. So instead of going for node splitting, we will be going for key redistribution. कौन सा element जाएगा? 16, 17, 18, 19. So 16 will go up. This 16 will go up and 14 will come down. So here we'll get 10, no node split took place. 16, left side pe there are no changes. So here we have the elements 1, 2, 4, 5. Here we have the elements 12, 13, 14. Still one slot is empty. And here we have the elements 17, 18, 19 and 20. आप check कर सकते हो जो 16 से smaller elements, those are on the left side, greater elements are on the right side. Okay, so next element is 15. 15 is smaller than 16, so going to the left side, one empty slot is available. That's fine. Now 25. 25 should come here, but in this case there is this is a case of overflow. Sibling bhi full hai, so in this case we have to go for node splitting. So third node splitting will be taking place and it will be splitted on the basis of 19. So at the root level we'll be having three elements 10, 16 and 19. To the left we have the elements 1, 2, 4, 5. 1, 2, 4, 5. To the left we have 12, 13, 14, 15. And here we have the elements 17 and 18. And here we have the elements 20 and 25. Will you be able to finish this? Or let me finish it. Okay. 23. So 23 will be coming here. Then is 24 and 25. Now next element is 22. So this is a case of overflow. So if 22 is coming up, then it will be a case of redistribution. So here we'll get 20 and 19 will be coming here. Okay. तो जब यहाँ पे आपके पास 20 आया, so ultimately this node will be having elements 23. 20 is going up. 22, 23, 24 and 25. This will be the key. I'm not constructing the whole tree again. So here key redistribution took place because it was resulting into the case of overflow. Next one is 21. Since 21 is greater, 21 is greater than 20, so it will be going to the right side. Again, this is a case of overflow. So again, the key redistribution will take place. Here we'll get 21 and here we'll get 20. There will be no change. Again, key redistribution took place. Now 30 is coming up. अब left child भी full हो चुका है, right भी full है. So this is a case of overflow. So the node split will take place. 22, 23, 24, 25 and 30. So node will be splitted on the basis of 24. So finally here we'll get number of levels increase nahi hue. 10, 16, 21 and 24. Left यहाँ पे same रहेगा. There will be no change. And here we will be having 22 and 23. And here we'll be having 25 and 30. 25 and 30. Take the next element. This is 31. So we can add 31 in the existing node. 28 we can add here. कोई problem नहीं है. 29. In case of 29, we have to go for key distribution. So here we'll get 25, 24 and the right node. I'm just constructing the right node here. Okay, this is over now. I'm constructing the right node here. Here we have the elements 29, 28, 29, 30 and 31. Have you observed one thing? In the previous case, for the same set of elements, there were 3 levels, but now we just have 2 levels here. Let me put here dot dot. That means same nodes are here. Guys, is this concept clear? So this is the benefit of key redistribution. Very, very important concept. This is very, very important concept. Okay, so you have to use this concept if it is asking for minimum number of, if it's asking for minimum number of node splittings, That means we have to use the concept of key redistribution. Is this clear? Yes? Guys, quickly give me the confirmation. One more concept I want to discuss, that is the concept of left biasing and right biasing. Here we are given with the degree 4. Degree 4 means maximum block pointers allowed are 4. Maximum keys which are allowed in a block are 3. So when I'm going to insert the elements, I'll be getting here 5, 10, 12. इसमें कोई problem नहीं आएगी. 5, 10 and 12. When I want to insert the fourth element, this is a case of overflow. So in that case, we can go for key redistribution, but यहाँ पे key redistribute नहीं हो सकती because the element is already there is only one node and that is full. So here we have to go for key redistribution. Key किसके basis पे redistribute करते हैं? On the basis of the middle element. Here we are getting two middle elements, 10 and 12. So you can go for either of the node splitting. That is, I can split this node on the basis of 10. Okay, so I'm just keeping one element on the left hand side and two elements are present on the right hand side. Since more number of elements are present on right hand side, so this is known as right biasing. This concept is known as right biasing, and if we are going to divide this node, we are going to split this node on the basis of 12. So we'll be having two elements on the left hand side. More number of elements are present on the left hand side and one element is present on the right hand side. Since more number of elements are present on the left hand side, so this is known as left biasing. Now question arises is which approach we have to follow. You can go for any method. You can either go for left biasing or right biasing, but not a combination of both. Can follow either left biasing or right biasing, but not combination of both. दोनों का combination नहीं ले सकते. So let's apply this concept. Let us assume that we are going for right biasing. I'm following here right biasing. आप कुछ भी follow कर सकते हो. That means more number of elements will be present on the right hand side. So node will be splitted. That means I'm splitting the node on the basis of 10. So here at the root level, we will be having the element 10 and to the left, we are having 5. The sole purpose of taking this example was to get comfortable with the concept of left biasing and right biasing. Otherwise, key redistribution and all those things we have already covered. So I'm taking this as 12 and 13. One more key can come here. So 5, 10, 12 and 13 are added. Next one is 14. Since 14 is greater than 12, so it will be going to the right side. 14 inserted. Then we are getting 1. 1 is smaller than 10, so we'll be getting here 1, 2 and 5. Next one is 4. This is a case of overflow. हमने क्या बोला यहाँ पे key redistribution, already we have discussed that. So 1, 2, 4, 5, who will be going up? 5, and this will be coming down. That means it will result into a root node with the key 5, and to the left of 5 we will be having the elements 1, 2, 4. Smaller elements are present on the left hand side and greater elements, that is I'm so sorry, here we had already 3 elements, so it's a case of full. Sibling is not ready to help, so we have to go for node splitting. here we have to go for node splitting because maximum keys आपके पास 3 आ सकती हैं. So node will be splitted on the basis of a 1, 2, 4, 5. हमने क्या follow किया? Right biasing. So this means that splitting will be taking place on the basis of 2. 1, 2, 4, 5. We want more elements on the left hand side. Right hand side. So we'll be doing the splitting on the basis of the key 2. To the left, we have one element, that is 1 only. To the right, we have two elements, 4 and 5. To the right of 10, we have the elements 12, 13 and 14. 12, 13 and 14. Now next key is coming up, that is 20. 20, this results into a case of overflow. So left sibling is ready to help. So 12 will go up. यहाँ पे हम redistribute करेंगे keys को 10. And definitely here we'll get 13, 14 and here we'll get 20. Make sense? Next one is 18. So for that, we need to go for the node splitting. Is this clear? For this, we need to go for node splitting as the left sibling is not ready to help. That is also full. So किसके basis पे node split होगी? This comes out to be 13, 14, 18 and 20. So definitely it will be splitted on the basis of 14. So finally we'll get here 2, 4, 2, 12 and 14. You can try this without key redistribution and calculate the number of levels and the number of node splittings. So finally here, final tree is 1. Here we'll be having 4, 5, 10. Here we'll be having the element 13 only. And here we have the elements 18 and 20. Okay. So this is about left biasing and right biasing. So in the insertion, we have looked at the concept of inserting the elements in a tree with odd degree and with even degree. दोनों cases के हैं. Then we talked about the concept of key redistribution. We talked about the concept of left biasing and right biasing. So this is about all the cases of constructing a B tree. Anyone having any doubt? हमेशा splitting leaf से node कहाँ पे जा रही है? Key is going from the leaf level to the internal level. So we can say that all the leaf nodes are at the same level in a B tree or B plus tree. Make sense? Any doubt or confusion or question? If this basic structure is clear, then let's derive few formulas, general formulas, and then I'll go through one question that can be asked in the exam. It is saying that we have to find out the minimum number of keys in a B tree with height h and order p. If order is p, minimum number of keys we want, order is p means maximum block pointers. So on the basis of this, we can get the minimum block pointers. कितने होंगे? p by 2. But अगर fraction में value आएगी, then we have to take the seal value. If minimum number of block pointers are p by 2, then minimum number of keys in a node will be p by 2 minus 1. Right? So let's follow that concept. अब हमें यहाँ पे general formula चाहिए with height h. Okay, root की height कितनी होती है? Root is at height 0 and level 1 level obviously will be considering. So here we are having the height. Let us consider the height. Minimum number of nodes, minimum number of block pointers, and minimum number of keys. First of all, let's talk about the height 0. Height 0 means we are having the root node. रूट पे हमारे पास मिनिमम नोड्स कितनी होंगी, मिनिमम एंड मैक्सिमम नोड एट द रूट लेवल. रूट इज ऑलवेज यूनिक, सो देयर विल बी ओनली वन नोड. मिनिमम नंबर ऑफ ब्लॉक पॉइंटर्स, मिनिमम की कितनी हो सकती है, देयर इज द एक्सेप्शन फॉर द रूट लेवल. सो मिनिमम एक की तो होगी. अगर एक की है तो ऑब्वियसली ब्लॉक पॉइंटर्स विल बी 2, which is independent of the order of a tree. Next one, at the next level, at the next height, height 1, agar previous level pe, okay, let me construct here. If there is one key, there are 2 block pointers. Agar 2 block pointers hai to at the next level this will be representing the number of nodes. So that means there will be 2 nodes. Now in each node, how many keys, how many block pointers will be there? In one node, minimum block pointers are p by 2. हर नोड में p by 2 block pointers है. Minimum p by 2 block pointers are there, but there are 2 nodes, so I'm going to multiply it with 2p by 2. That means at height 1 we will be having 2 into p by 2 block pointers. What will be number of keys? In each node, minimum number of keys are p by 2 minus 1. But here we have 2 nodes, so we'll be multiplying it with 2. Make sense? Same process will continue until we observe some series at height 2, at height 3. This way we will be calculating it till height h. So at the next level there will be 2. अगर जितने block pointers है next level पे उतनी आपके पास nodes बन जाएंगी. In each node the number of block pointers are p by 2. p by 2 block pointers are there and number of nodes are 2 into p by 2. So simply we can write this as it's 2p by 2 whole square. And here we have these many nodes, and in each node there are p by 2 minus 1 keys. Are you getting this? Same way we will continue here. 2p by 2 square. Previous level पे जितने block pointers है that will become the number of nodes at the next level. So here we'll get 2p by 2 cube. 2p by 2 square are the number of nodes, and in each node number of keys are 2p by 2 minus 1. So have you observed some pattern? अगर यहाँ पे आपके पास height 3 है then it's raised to power 2. If it's height 1 or 2 then it's raised to power 1. अगर 1 है then it's p by 2 raised to power 0. So this means that if it's height h, we will be getting here 2p by 2 h minus 1. Here it comes out to be 2p by 2 h. अगर height 1 है then it's raised to power 1. If height is 2 then it's raised to power 2. If height is 3 then it's raised to power 3. If height is h, it will be raised to power h. Minimum number of keys, again observe the pattern here. जितनी भी आपके पास nodes हैं p by 2 h minus 1, and here we have the number of keys in each node. So we have got this. अब आप देख लो कि आपसे क्या पूछा हुआ है. If it's asking for the minimum number of keys with height h, तो आप इन सारी terms का sum ले लोगे. If it is asking for minimum number of block pointers, then you will take the sum of all. And if they are asking that how many pointers will be the null pointers, since minimum number of block pointers height h means it is representing, if it's representing the root level, तो height h is representing the leaf level. लीफ लेवल पे ब्लॉक पॉइंटर्स नल होते हैं. मिनिमम नंबर ऑफ ब्लॉक पॉइंटर्स दैट विल बी इक्वल टू नल इज 2 into p by 2 raised to power h. What I'm saying is minimum number of block pointers pointing to null, this can also be asked in the exam, pointing to null is equal to 2 into p by 2 raised to power h. You can note it down in your short notes. अगर आपको फॉर्मूला याद रहता है तो बहुत अच्छी बात है, नहीं याद रहता है तो you can derive it. Here we were supposed to find out the minimum number of keys, so let's find out minimum number of keys. What we need to do is we'll be taking the sum of all of these terms. Minimum number of keys, here we have 1 plus 2 into p by 2 minus 1 plus 2 into, I'm taking the sum of all the terms, p by 2 minus 1 and so on. This way it will be going till 2p by 2 raised to power h minus 1. Hope this is not going behind the image. Let me add it. P by 2 minus 1. You can observe here p by 2 minus 1 is a common term, so we can take this as common. It comes out to be 1 plus 2p by 2 minus 1. I'm taking this term as common. So ultimately here we are left with 1 plus 2p by 2. 2 already we have taken common. So 1 plus p by 2. From this term, this is taken common. P by 2 square here will be getting and so on up to p by 2 raised to power h minus 1. Now this is nothing but this is a GP series. Here we are getting a GP series with first term as 1, common ratio as p by 2 and number of terms here are raised to power 0 से लेकर it is going till h minus 1. So that means the number of terms are coming out to be h. Apply the formula for the GP series. That is nothing but a r raised to power n minus 1 upon r minus 1, because here the common ratio is greater than 1, right? So I'm using the formula for the GP series. So when you'll simplify this, it comes out to be p by 2 minus 1 and here we'll get 1 plus 2. Here this is the GP series p by 2 raised to power 0. So that is first term and common ratio is p by 2. Number of terms are h minus 1 divided by r minus 1, p by 2 minus 1. Now you can see here these two terms gets cancelled out because in the numerator and denominator we are getting the same term. So ultimately this is returning 1 plus 2 p by 2 raised to power h minus 1. So this is representing the minimum number of keys. Clear? इसी तरीके से आप मिनिमम नंबर ऑफ नोड्स फाइंड कर सकते हो. हियर अगेन यू विल बी गेटिंग द जीपी सीरीज. आप देख सकते हो मिनिमम नंबर ऑफ नोड्स है, मिनिमम नंबर ऑफ ब्लॉक पॉइंटर्स है और मिनिमम नंबर ऑफ कीज है. इट्स सिंपली रिटर्निंग द मिनिमम, इट्स सिंपली forming a GP series. The way we have calculated for the minimum number of block pointers or minimum number of keys, similarly we can find out the maximum keys already we have calculated. So those who are new guys, I'll be sharing this PDF in the Telegram group. So you need not to worry about getting the notes. I hope you all are getting the concepts. Instead of focusing on taking down the notes, you are focusing on understanding the concepts, right? So on daily basis, I share the PDF of all the YouTube sessions and the Telegram group, that is Shefali Ma'am Testbook. You can search it out or you can also follow the link that is given in the description box. Give me 15 to 20 minutes more and then I'll show you that where is that link available. And apart from that, you can also participate in the doubts and the discussion sessions. You can directly interact with me, participate in the quiz and the polls, so that you can keep track of your preparation level. Okay. All right. The way we have calculated for the maximum minimum number of keys, similarly we can find out for maximum number of keys. So here also we'll consider the height. 0 means we are talking about the root node, and maximum number of nodes, maximum number of block pointers, and here we have maximum number of keys. At the root level, what can be the maximum number of nodes? Root means root हमेशा unique होती है, so it will be 1 only. But maximum number of block pointers, since here the order of a tree is given as P, so maximum block pointers will be P only, right? So maximum number of block pointers will be P, and maximum number of keys will be P minus 1. Maximum key will be P minus 1. At the next level, at the height 1, the number of block pointers will be representing the number of nodes. For each node, maximum block pointers are P, and there are P nodes, so it will be P into P. That comes out to be P square. For each node, there are P minus 1 keys. हर एक node के लिए P minus 1 keys है, but at height 1 we have P nodes. P nodes है, एक node में P minus 1 keys है, so we'll be taking this as P minus 1. Similarly, we'll find out for up to height h. We'll get the series, we'll take the sum. So here the number of nodes will be P square. It will be number of block pointers will be P into P square. That comes out to be P cube. And here it will be P square P minus 1. P cube, it will be P raised to power 4 and P cube into P minus 1. If it's height h, if it's height 3, then it's raised to power 3. Height 2 is raised to power 2. Height h means P raised to power h. P raised to power, maximum number of nodes are P raised to power h. Maximum number of block pointers will be P raised to power h plus 1. P raised to power h, again it's going behind the image. Okay. P raised to power h nodes हैं, हर एक node में P minus 1 keys हैं. So we have got this. Now we want to find out the maximum number of keys. Maximum number of keys, यानी कि जो keys वाला column है, just take the sum of all those terms. So we are getting here P minus 1 plus P into P minus 1 plus P square into P minus 1 plus P cube into P minus 1 and so on. This way we are going till height h. Now from all these terms we can take P minus 1 common, and now this is resulting into 1 plus P square plus P cube and so on up to P raised to power h. This is a GP series. ये GP series है with the common ratio P. We are getting a GP series with common ratio. Common ratio is represented by R, so that is P. First term of the series is 1 and number of terms in the series are raised to power 0 से start होकर it is going till h. That means h plus 1. Formula for this series is S of n will be equal to A r raised to power n, number of terms minus 1 upon r minus 1. Just substitute that here. So here we'll get P minus 1. A is 1. R is P. Common ratio is P. Number of terms are h plus 1. Number of terms are h plus 1 minus 1 divided by P minus 1. This gets cancelled out. So ultimately we get here P raised to power h minus 1 minus 1. These are the maximum number of keys. And we know that height is nothing but that is one less than the level. अगर आपसे लेवल पूछा है तो आपको कुछ नहीं करना, सिंपली यू कैन फॉलो दिस अप्रोच. सो हाइट कितनी होती है, जो भी लेवल होता है वन लेस देन द लेवल. तो अगर आपसे विद लेवल पूछा है देन जस्ट सब्स्टिट्यूट द वैल्यू हियर. सो h is L minus 1 plus 1 minus 1. So that comes out to be P raised to power L minus 1. This is with level 1. Okay. So this is all about the concepts of the B tree. Anyone having any doubt? So I'm giving you few questions. Here we have the questions. You can identify it. I'm so sorry. As we are running out of time, because I have to give you a quick overview of B plus tree as well. So you can try this question in your assignment and we'll discuss this solution in the master class. In this question, we have to identify the maximum number of nodes and the keys in B tree with order 3 and level 4. Okay, level के basis पे पूछा है, अभी हमने maximum number of keys find किया है. Same way you have to follow. Either substitute the values in the formula, but I won't recommend you that because उसके लिए आपको formulas याद रखने पड़ेंगे. Better idea is the way we have derived the formulas, in the same way you can come up with the number of keys. This is the next question. You can also cover this in the assignment. In tomorrow's master class, कल वाली master class B3 or B plus 3 के basis पे होगी. So first of all, I'll be covering these assignment questions. Then we'll discuss the previous year questions. Okay. So next one is B plus 3. B plus 3 is kind of similar to B3. The only difference is need to maintain a copy. Need to maintain a copy of every key. Need to have or need to, not every key, only the splitted key. Let me write. Okay, जो की already आपके पास leaf level पे उसकी copy नहीं maintain करेंगे. Need to maintain a copy of the splitted key at the leaf level. बाकी सब कुछ same है. At least 50% occupancy should be there within a node. All the elements, all the keys should be in the ascending order. Left keys, left block will be containing the keys which are smaller than the key, and right side पे जो keys greater है that will be going. So वो सारी चीजें same है as that of B tree. The only difference is need to maintain a copy of the splitted key or splitted node at the leaf level. That means first time जब splitting होगी उस time पे we will be maintaining the copy. Second time जब internal level से internal level पे जा रहे हैं then we need not to maintain a copy. Because idea behind this is we should have each and every key at the leaf level. So if we talk about the structure of the internal node, we have although already talked about this internal node and leaf. What is happening? Just a minute. Leaf node. So here the idea is to have each key at the leaf level. And since one block will be pointing to the next block, so it will provide a sequential access. Okay, since each key is available at the leaf level, तो हमें internal level पे record pointer की जरूरत नहीं है, क्योंकि जब आपको key को refer करना है तो each key is available at the leaf level and will be maintaining the record pointers at the leaf level. So at the leaf level, if the order is P, let us assume that order is P, so maximum number of keys, minimum number of keys, it will be same. So here we'll be having the block pointers. This is key 1, key 2, key 3. Every key will be available at the leaf level P minus 1. Along with this, there will be a record pointer. Record 2, record 3, record pointer P minus 1. These will be null as this is a leaf node. It will be null. But there will be one block pointer because we want the sequential access. So there will be one block pointer that will be pointing to the next block. So on the basis of this, we can come up with the formula. Can somebody tell me that what will be the formula? Here for order P, we are having P minus 1. We are having P minus 1 keys. P minus 1 record pointers are there. And there is one block pointer available at the leaf level which is pointing to the next block. And it should be less than equal to block size. Whereas if we look at the internal node structure, internal node means it will be having the block pointers. So let's consider this is block pointer 1, block pointer 2, block pointer 3. Like this, we will be having P block pointers. This is key 1, but here will not be maintaining any record pointer. Key 3 and so on up to kp minus 1. ये जो internal level पे आपके पास keys आ रही है, इन सबकी copy already हमारे पास leaf level पे. That's why along with the key, we are not taking the record pointer at the internal level. This is one formula. Next one. Here for the internal node, we have P block pointers. We have P minus 1 keys. And there is no record pointer. This should fit into one block size. Should be less than equal to a block size. This is the formula for the internal node of a B plus tree. बाकी differences हम लोगों ने कल किए थे. जिन लोगों ने कल वाला सेशन नहीं देखा है बेटा एक बार कल वाला सेशन देख लेना. It will be helpful. Is this clear? This is the difference between the B tree and the B plus tree. Now let's see how to construct a tree, how to maintain a copy at the leaf level. So I want to construct a B plus tree with the order 4. Order 4 means maximum block pointers will be 4 and maximum keys will be 3. Baki sara concept same hai, maximum keys will be 3. Now let's try constructing the B plus tree. Jab tak node splitting nahi hui, rest everything is same and minimum number of okay. So here first of all we'll be taking 5, 10 and 15. कोई problem नहीं है. 5 आया, no issue. 10 आया, कोई problem नहीं है. 15 आया, कोई problem नहीं है. Now next element 8 is coming up. When it's a case of overflow, then we'll go for node splitting. This is a case of overflow, so we are going for node splitting. Now, in this case, node will be splitted on the basis of what? 5, 8, 10 and 50. We can go for, जब भी ऐसा scenario होता है तो we can go for left biasing or right biasing, right? Because here we are getting two middle elements, तो हम 8 के basis पे भी split कर सकते हैं और 10 के basis पे भी. This is same as that of what we have covered in the B tree. Right biasing. Let us assume that I am following here right biasing. Even है तो हमें biasing का concept use करना पड़ेगा. I am considering right biasing. Now, the node will be splitted क्योंकि right biasing follow कर रहे हैं तो node splitting किसके basis पे होगी? 8 के basis पे. So 8 is going to the root level and to the left of 8 we have 5. ये point बेटा ध्यान से समझना because this is going to tell you the difference between B tree and B plus tree node splitting. Okay, and the remaining elements, greater elements, are on the right side. ये तो हो गई बी ट्री की नोड स्प्लिटिंग. जब हमें बी प्लस ट्री का कॉन्सेप्ट चाहिए तो जो नोड लीफ लेवल से इंटरनल लेवल पे गई है इसकी कॉपी लीफ लेवल पे नहीं है. We have to maintain its copy at the leaf level. So what we'll be doing here is we can make its copy either on the left side or right side. But make sure अगर आपने first element की copy left side पे maintain की है तो सारे node splittings के लिए you'll be maintaining the copy on the left side. In this case, I'm going to maintain its copy on the left side because right side पे already दो element है. If I'll be taking third element as well, I'll be taking the copy on the right side तो node full हो जाएगी. I don't want that. So I'm maintaining the copy on the right side. This is also possible. You could have taken, I'm not saying it's incorrect, but since we are focusing on the minimum number of node splittings, so that's why I'm taking the copy on the left side. Okay, so both are possible. In this case, I'm taking the copy on the left side. In this case, I'm taking the copy on the right side. अगर ये मैं येलो वाले पोर्शन को हटा दूं, it will be representing the case of the B tree. Anyways, let's proceed with this part only. Now in this tree, I want to insert the element 20. Since 20 is greater than 8, so it will be going to the right side. No node splitting is taking place. 3. 3 is smaller than 8, so it will be going to the left side. So here we'll get 3, here we'll get 5, and here we'll get 8. Take the next element, that is 1. So with 1, that is a case of overflow. So it comes out to be 1, 3, 5, 8. Since we are using right biasing, so 3 will be going to 3 is moving from the leaf level to the internal level. जब first time leaf level से internal level पे जा रहे हैं तो we need to maintain the copy. 3 and 8. 3 के left पे we have 1 only, and since we are maintaining the copy on the left side, so its copy will also be present in the left block. To the right of 3 we have 5 and 8. To the right of 8, we have 10, 15 and 20. There will be no change. So have you observed one thing? अभी तक आपके पास कितनी keys, जितनी भी keys आई हैं, all are present at the leaf level. And second thing is the copy of 3 is present on left side. Copy of 8 is present on left side. Next element is 0. Since 0 is smaller than 3, so we'll be going to the left of 3. Here we will be arranging the elements 1 and 3. This is the resultant B plus tree from the given keys. So we were given with 3, 6 and 8. 8 keys were given and all the 8 keys are available here. There will be one block pointer that will be pointing to the next node. One block pointer is available at the leaf level which is pointing to the next node, and this supports the sequential access. I hope that this is also clear. Formulas for both internal node and leaf node we have already covered, so you can go through it. So you can try with more number of keys. You know that how we have to construct the tree. So this is with order 4, just I have added few more elements. Okay, this is for your practice. Here you have to apply the formula. This question will also be covering in the master class. Just go through the question. Everything is given in this one. And if you are facing any difficulty, you can ask that in the master class. So this is all from my side. In another 10 minutes, I'll be sharing this PDF with you guys. आपके पास आज का पूरा दिन है. Okay. कल भी हमारी क्लास 8 बजे होती है मास्टर क्लास, तो you will get approximately 1.5 days to go through all these concepts, to try the questions. In case you are facing any difficulty, feel free to post that in the Telegram group. I'll give you the response. और अगर पूरा कॉन्सेप्ट या कोई ऐसा कॉन्सेप्ट है जो एक्चुअली लाइव सेशन में ले सकते हैं, so I'll take that in tomorrow's master class. Apart from that, you can directly interact with me. Quiz and polls are also there. Currently, guys, Mahabajat sale is going on. We are not covering like 100% syllabus completion. Won't be there on the YouTube. So if you want to cover 100% syllabus along with the recorded sessions, live sessions, notes, quizzes, everything, then you can go for the super coaching. And currently, the Mahabajat sale is going on. That is till 31st of May. So in this, you will be getting 70%, 75% plus 25% off along with the 50% extra validity. This means that if you are going to purchase 1 year course, तो आपको 6 months की extra validity मिलेगी. 2 year course पे आपको 2 plus 1 मिलेगा. 3 year course पे 3 plus 1.5. इतने में तो आपकी बीटेक की डिग्री खत्म हो जाती है. So I'll not suggest you to go for 3 year course, but definitely you can opt for 1 year or 2 year. In order to get the maximum discount, you can use the coupon code that is Shefali S. Let me quickly share my screen so that you guys can get an idea that how you can use it. I hope that my screen is visible. So currently the session is going on. When you go to the description of this video, you can see here this is the first link for the masterclass. Using this link, you can join the masterclasses which are going on. जो मैंने आपको assignment questions दिए ये हम इस masterclass में cover करेंगे. And apart from that, if you are targeting on NIC super coaching, you can use the second link. In order to join the Telegram, you can see here join Gate super coaching Telegram. तो इस Telegram group को join करने के लिए you have to follow this third link. Okay. And next one is if you want to join the super coaching benefits मैंने आपको बताए and here is the code given in the description. So let me click on this in order to quickly show you that what all things you'll be getting here. So first of all, you will be getting the recorded sessions, live sessions. So recorded sessions के लिए you have to go to the courses. Subject-wise course and full courses are available. Full courses are provided by the Gate Forum, Digimento, Nimbus Learning, and Testbook itself. That is by me and my team. So you can have the look over the rating. चारों courses की rating बहुत अच्छी है. So you can follow any faculty. It's completely your choice. And apart from that, you can have a look over the profile of the super teachers. Demo classes are there. And live series जो अभी currently चल रही है that you can join. Mock tests will also be included. आपको अलग से टेक्स्टबुक पास प्रो लेने की जरूरत नहीं है. Study notes will be available in the PDF format for all the subjects: engineering mathematics, general aptitude, formula notes, and engineering science. Engineering computer science में आपके पास सारे के सारे technical subjects आ जाएंगे. For each unit we have a separate PDF. So you can see here we have a separate PDF, but currently this is under the lock. I cannot show you that how these notes looks like, but each and every concept will be covered in detail in the detail notes. We have separate formula notes for each and every subject. In these formula notes, आपने देखा होगा यहाँ पे एक ही PDF है, so it is just containing the important set of formulas and the points that you have to keep in mind. Formula notes are basically beneficial when you are your exam is approaching and you have to quickly revise the concepts. Okay. Now let's go to the final step, that is the pricing. So you can see here we have three plans available: 1 year plan, 2 year plan, and 3 year plan. 1 year पे up to 31st of May, you will get 50% extra validity. So 12 plus 6, 12, 24 plus 12, and 36 plus 12. तो आपने देखा होगा this is the maximum discount that you can get. 3 year subscription is just for 12,674. तो prices और drop हो गए, and but this is valid only till this much time. Okay, so you can take the full benefit of that, and in order to get a full advantage and maximum discount, don't forget to use the code Shefali S and just click on apply. Okay, so this is all from my side. If you guys have any doubt or any query, you can ask. Otherwise, I'll see you at 8 p.m. in the masterclass, in which we will be covering the concepts of, we will be covering the previous year questions on database design. Already concepts are over. We have covered that in the masterclass. So, guys, tomorrow we will be talking about timestamp based protocols, because when we talked about transaction and concurrency control, the timestamp based protocol was left out. So, tomorrow In the YouTube session, we will be covering timestamp based protocols, and in the master class, we will be covering the practice questions plus previous year questions on B tree and B plus tree. Apart from that, we are daily having 2 sessions from Monday to Friday. Both the sessions are free as of now. So it's 4 p.m. to 5 p.m. Today topic was a bit lengthy. So I took some extra time, 4 p.m. to 5 p.m. and this is from 8 p.m. to 8:30 p.m. This is the master class, टेक्स्टबुक मास्टर क्लास जो टेक्स्टबुक प्लेटफॉर्म पे होगी एंड दिस इज द यूट्यूब यू नो दैट हाउ टू फॉलो दिस सेशन इन द यूट्यूब वी आर targeting on the concepts learning whereas जो भी concepts हमने learn किए हैं we are applying those concepts in the master class while solving the previous year questions. Apart from this, Saturday and Sunday will be having the marathon sessions. Either I'll be taking a 1 hour session on both the days, or I'll be taking the marathon session on either of the day. Okay. So marathon session timings will be timing and link will be posted in the Telegram group. क्योंकि मेरे पास communication करने के लिए सिर्फ एक ही method है, that is the Telegram group. That's why again and again I focus on one point that guys join the Telegram group so that you get updated and you get the links of all the sessions. So marathon sessions will be there on the weekends. So this is about the schedule and this is all from my side. If you guys have any doubt or query, you can ask. Otherwise, we'll end our discussion. All right. So I guess it's clear for everyone. So I'll see you at 8 p.m. Thank you so much, guys.